Hello everyone. Now in this discussion, we are going to look at how we can use the mid-ordinate rule. The guiding question says use the mid-ordinate rule to estimate the area enclosed by the curve y is equal to x squared minus 9. Then x-axis and the lines, okay, x is equal to 2 and x is equal to 4 using 7 ordinates or 6 strips. So once you're given such a number, you have to understand that using the mid-ordinate rule, I need to look at the interval. So the interval is from, so A is equal to 2 and B is equal to 5. What is H? H is the width of each sub-interval, okay? And it is the same as B minus A divided by N, whereby N is the number of sub-intervals. So how can we get this? We are going to say H is equal to B is 5 minus 2 divided by N. N is 7 minus 1. Because if you are told to look for, to use a particular number of ordinates, then the number of subintervals are always going to be the number of ordinates less 1. So number of ordinates are 7, and therefore the number of subintervals we are going to use is going to be 6. So this is 3 out of 6, and this is 0.5. Meaning we are going to divide this interval from 2 to 5, okay, into how many strips? 6 strips or 6 sub-intervals. Therefore, we are going to start from 2, okay? So 2, the width of each sub-interval is 0.5. So we shall be going to 2.5 to 3.0 to 3.5 to 4.0, then 4.5 up to 5.0. So when we look at this, we already have our ordinates. Now these ordinates are 7. 1, 2, 3, 4, 5, 6, 7. And the number of strips or sub-intervals is going to be 1, 2, 3, 4, 5, 6. So now, if we are using the mid-ordinate rule, we need to look for the midpoints of each sub-interval. So if this is the first sub-interval, what is the midpoint of 2 and 2.5? So that midpoint is going to be 2 plus 2.5 divided by 2, which gives us 2.25. Then what is the midpoint here? 3 and 2.5. This is going to be 5.5 divided by 2. So this is going to be 2.75. So the moment you get 2.5 minus this, you see there is a difference of 0.5, which is H. So meaning I can just add 0.5 so that this becomes 3.25, and this becomes 3.75. This becomes 4.25, and this becomes 4.75. That is our last value. If I count these are going to be how many? The number of strips is always going to be the number of mid-ordinates. So you can see 1, 2, 3, 4, 5, 6. So meaning the points that I'm going to be substituting in this function f of x, okay, is going to be 2.25. They are going to be the midpoints. So I'm going to put here 2.25, 2.75, 3.25, then 3.75, 4.25, and lastly 4.75. You can see all these are lying within the interval 2 to 5. So what is the value of 2.25 when I substitute it in here? So this is the same as if this is y, so I can as well say f of x is equal to x squared minus 9, so that it becomes f of 2.25. And what is the value here? me I'm getting negative 3.9375. What if I put in 2.75? I get negative 1.4375. If I put in 3.25 on my calculator, I'm getting 1.5625. Then substituting 3.75, what do you get? 5.0625. If I put in 4.25, what do I get? I get 9.0625. If I put in 4.75, I'm getting 13. I'm getting 13.5625. So once I'm through getting these points, remember this is going to be my y0, y1, y2, y3, y4, and this is y5. So I know that from the mid-ordinate rule formula, integral from a to b f of x is approximately equal to h into y0 plus y1 plus y2 plus dash dash up to plus yn. Now, my n here being up to number 6, okay? 1, 2, 3, 4, 5, 6, up to 6. So, but I have yn, okay? So yn probably minus 1, because if n is 6, then it means I will end. If I start from 0, y0, then I will end at yn minus 1. And therefore, this is going to be h. Okay, now the integral, okay, we are integrating from 2 to 5 of x squared minus 9 with respect to x. Because if you are looking for the area enclosed by this curve and the x-axis at points x is equal to 2, x is equal to 5, it is the same as integrating that particular area. And therefore, if I know my h is 0.5, okay, then I know my y0 into y0 plus y1 plus y2 plus y3 plus y4 plus y5. I'm going to substitute in those values. So this is going to be negative 3.9375 plus negative 1.4375 plus 1.5625 plus 5.0625 plus 9.0625, finally plus 13.5625. And when I calculate this, I get my area, okay? This is 0.5 plus this times this and that. My final answer is 11.9375, and this is 4 decimal places. Okay, if we wanted to integrate this manually, like getting a direct integral, then you can say integrating x squared, this is from 2 to 5 minus 9, okay, with respect to x. This is going to be x cubed out of 3 minus 9x from 2 to 5. And this is going to be, I put in 5 here, divided by 3, that is 125 out of 3, minus 9 times 5, that is 45. Okay, then I take away 2 cubed, that will be 8 out of 3, minus 9 times 2, which is going to be 18. So on my calculator, if I do that very fast, I have 5 cubed divided by 3 minus 45, then I subtract, okay? I subtract. This is going to be 8 divided by 3, then 8 divided by 3, then minus 18. So this is giving me 12. So now you can see that this is also approximately equals 12. So if I get minus 11.9375, I get an error. So the error is 0.0625, and this is very small. And okay, some areas you might find this is not so small, and you don't need to neglect it, but you can see this answer is approximately to this, so you can go with this. So you find the mid-ordinate rule is able to give you the area that you need, that is approximate to the exact that you need using the analytical methods, because numerical methods are an opposite or an approach that is giving you an alternative to the analytical methods. So that's all. Thank you for tuning in.